All right, we're going to be working linear systems in two variables. I'm on my website here. We're gonna go through here and select a problem, and I think we'll do this one right here. The link to this website is on my YouTube channel. On the right hand side, you'll see Intermediate Algebra. Okay, so we've gone to the whiteboard. So I've got my system written out right here, and what we're going to want to do is we're going to want to solve for x and solve for y. Well, look here, x is equal to 7, so that was given to us, so that's nice. So now we want to take this 7 and go up to this equation here, plug it in for x, so we have 7 plus y is equal to 12, and then we just solve this linear equation and solve for y. So this becomes y is equal to, bring this 7 over to the other side makes it minus 7, and so we have y is equal to 5. Alright, so that we can check our work by taking both of our x's and our y's here and plugging them in, right? So 5 plus 7 is 12. Right? So we can always check our work. We can also write this as an ordered pair, 7y or 7 5, considering this is our x and this is our y. And let's look at a graph of graphing both of these equations here. Okay, so the vertical line here is going to be the x is equal to 5, and then this is the this line here represents the that first equation. I believe it was at the top there. But we solved for y in that problem, and we got y is equal to negative x plus 12 in order to graph this. Well, do you see where the two graphs intersect? Alright, this is the point that's in common with both of these lines right here, and that's what we're looking for. We're looking for this point of intersection, which, as you can barely see here, at 5 we go 5 and then go straight up, and it looks like it's 7 units on the y-axis here. So 5 7 was our solution. Let's do another one. Okay, so let's scroll through and see if we can get something different. There's a particular one here I'm looking for, actually. Okay, let's do this one here. Alright, so we had y was equal to 8 was one of our equations, and then our second equation is 8x plus 5y is equal to 88. Alright, so what I'm going to do is I'm going to take, since they already give us y, right, I'm going to go ahead and plug that in. That was nice of them to give us that. And now we have another linear equation. We just solve for x in this problem. So we end up with 88, bringing this over, this would be minus 40. And we have 8x. And so we have 88 minus 40. What's that going to be? Looks like 48. And then we want to multiply both sides by 1 over 8. So we can get a coefficient of 1 here in front of this x. And of course that's going to end up being 6. So now that we have both our x and our y, right? So x is equal to 6 and y is equal to 8, which they already give us. We could write this as an ordered pair, 6, this being my x and this being my y, and this would represent a point in the Cartesian plane, which we're going to go ahead and graph this out now. Alright, so the solution was 6, 8. Here's 4, 5, 6. We go up, and we're going to have to move this screen here so we can see it. Okay, so this is going to be the point right here, 6, 8. Right, that's going to be the point 6, 8. So there you go. So it helps out to be able to geometrically see what we're doing here. You know, when we're solving these systems of equations. Alright, so I'm going to work some more, several more. Alright, I'm not sure we ever came here and checked that actually. 6 and 8, okay, I do believe that's what we got. Alright, let's look for another one here. And that looks like a good one. So we got x and y's in both these equations. Alright. So let me just say that this method that we're using to solve this system of equations is known as just direct substitution. There are several different ways of solving this system, and I believe in my college algebra section we'd use matrices to solve this system. We turn it into a matrix equation, but I'm not going to get into that in intermediate algebra. Alright, so we're going to do the direct substitution, and what I'm going to do here is I'm going to go ahead and take let's see, what am I going to do? You know what, we'll solve for y first. Let's take the y over to the other side. So we're going to have x is equal to 5 minus y, and then I'm going to take this x and substitute it directly in right there, which is equal to 5 minus y. So we end up with 5 minus y plus 9y is equal to 21. And now we have an equation here with just one variable in it, and that means that one unique variable, and that means that we're going to go ahead and solve for y in this problem. So I'm going to have 5 plus 8y after simplifying that down, and then we'll go ahead and take this 5 to the other side, and so we have 21 minus 5. Okay. And of course we have 16. So now we're just going to multiply both sides by 1 over 8. So we can get a coefficient of 1 in front of that y. And so 8 goes into 16 two times. So we now have both of our solutions. Oh no, we just have y. That's right. Now what we can do is look at this guy right here to find out what x is. So x is going to be equal to 5 minus 2, and so we have x is equal to 3. And I'm going to actually just write this as an ordered pair, 3, 2. Alright, so we're going to graph this out and take a look at the graph. So we have 3, 2 is our solution. X is equal to 3 and y is equal to 2. But let's see what we got here. Let's see if we did it right. Yep, x is equal to 3 and y is equal to 2. Alright. Actually, you know what? I think I'll let you graph that out and take a look at that. Let's work another one. Let's see if I can find a different one here. There's a different one. Okay. It was x plus y is equal to 5, I believe. Or wait a minute. Is that what it was? No, that's not what it was. Alright, let me rewrite this again. I was looking at something else in my notes. X minus y is equal to 2, and x plus y is equal to 12. So I'm going to go ahead and solve for, what am I going to solve for here? I just solved for x in this problem. So x is equal to, in that first equation, 2 plus y. And then I'm going to take that and plug it in right there. So we're going to have 2 plus y, and then plus, and that would be this y here, is equal to 12. So we end up with 2 plus, and there's 2 y's here, so that'd be 2y is equal to 12 after simplifying that down. 2y is equal to, let's bring that 2 to the other side over here, so this becomes 12 minus 2. And now we're left with 2y is equal to 10, and then we want to multiply both sides by a half. And so we end up with y is equal to 5. So we know what y is. I'm going to look at this guy right here, because now we're going to be able to find out what x is going to be, and y is 5. So we have x is equal to 7. So we're going to have our ordered pair, if you want to write it like this, 7, 5, right? And of course, let's see what the answer is. Yep, there it is, 7, 5. So come to the website. I got tons of problems on this. You can work them out. Alright, so here's another set of equations here. We're going to solve this system if possible. x plus y is equal to 13, and x plus y is equal to 9. Alright, so we have x plus y is equal to 13, and yes, and x plus y is equal to 9. So what we're going to want to do here is solve for x or y in this problem. It doesn't matter. I'm going to go ahead and just solve for y again. Or no, I'm going to solve for x. So x is equal to 13 minus y. So you see I just took this y to the other side. And then I'm going to take this x right here, replace this x with 13 minus y. So we're going to have 13 minus y plus y is equal to 9. Alright, and simplifying, we have a negative y and a plus y, so that's going to cancel out to 0. And so the left hand side will be equal to, whoa, wait a minute there, Bessie. That's not possible. So something fishy's going on here. We get a number 13 is not equal to 9, at least not in the number system we're working with here. Maybe in another number system you could get that to happen, but what's actually going on here? Okay, let me just kind of sketch out the graph here. Alright, if we were to graph this, this thing's going to have, what is it going to have? I'll tell you what, I'm just going to solve for y in this problem. We got y is equal to negative x plus 13. There was a section where we did some graphing. This has a slope of negative 1, and it passes through the y-intercept at 13 up here, which means that it's going to pass down here through 13. And so if I could draw a straight line, okay, so, and then this one here is going to be the same way, except it's going to pass through here at 9. So the reason I'm drawing this out is so we can kind of better see what's going on here. Okay. What we got going on here is we got two lines with the same slope, and they're parallel to each other here, but they're not the same. Okay. And they don't intersect, so they're not intersecting anywhere. These lines don't intersect, and therefore if they don't intersect, then there is no solution. No solution, right? No solution. So I'm going to click the answer here, and it says no solution. Okay. So this is one with no solution. The slopes are the same. These are just two parallel lines, but they're distinct lines. They're distinct parallel lines. You know, they could be the same line. The same line means they'd have the same slope, and they'd both technically be parallel, I guess, and whatever. But no solution on this, and that is because we got down to this point right here and our variables canceled out. Alright, so if this happens, we got no solution. We're going to look at another case where there's an infinite number of solutions. So actually what I'm going to do now is we're going to kind of go through all the possibilities here of finding a solution to a system of equations, and what we're going to do this is we're just going to look at this graphically. Alright, going to look at this graphically. So what are our possibilities? Now I'm not going to draw the XY axis here. I'm just going to draw the lines in the plane. So our possibilities is here. We could have a line and then another line, and of course this is where they intersect. That's the point we've been looking for. We could have two parallel lines. Okay, we could have two parallel lines, so that means no solution, right? So this is no solution. Right, no solution. This means one solution. I'll just write x, y as ordered pair here. Right, so this is one solution. Now we got another possibility, and that other possibility is if we had a line, okay, and believe it or not, it's going to make sense, another line that's directly over the top of that line. Okay, so where these two lines intersect? Well, they intersect everywhere, right? I mean, they intersect. So every point, I mean, these two graphs here intersect at every single point, obviously, if they're on top of each other. Let's construct a, actually we'll just start over here with a new screen. And what I'm going to do here is I'm going to construct a system that has an infinite solution set. Let's say we had x plus y is equal to 10. Now I'm going to multiply, let's say 3, it doesn't matter, we multiply a number all the way across, and let's say we have 3x plus 3y is equal to 30. Well, it turns out these are, if we were to graph each one of these individually, it turns out that they'd be the same graph. And so in other words, basically is what we're saying here is so this would be like the line to this equation, and then if we were to graph this equation, it would just graph right over the top of it. So you see we'd have an infinite solution set. Now if I were to solve these systems, we would do something like, like I've been doing. I would solve for x in this problem, let's say, and so we'd end up with x is equal to 10 minus y, and then I would take this and plug it in for this x, this 10 minus y. So we'd have 3 times 10 minus y plus 3y is equal to 30, and of course we're wanting to solve for y in this problem, so let's see what happens when we do this. Alright, so the y's cancel out, negative 30y plus 30y, they're going to cancel out, and we're going to be left with 30 is equal to 30. So you see both sides of the equation are going to be equal to each other. Okay, and this is going to be a clue here that that there's an infinite solution set to this. Alright, whereas remember in the previous problem we got something like this where these weren't equal, which means no solution. But if they are equal, then that means there's an infinite solution set. But usually what you'll be able to do is, for example, if I multiplied 1/3 all the way across inside here, we end up getting this equation looks exactly like this equation up here. Alright, so good luck, get to the website, practice some problems. Alright.